In this diagram, you are given the diameter AC. Okay, you are also given a center, which is 4. You've got 4 chords there. The diameter of the 5th chord. Alright? And the first question says if ACB is equal to 33 degrees, determine with reasons the size of angle A1. Right? So our A1 is this angle here. That's A1. You need to determine that angle. Right. Before you answer this question, you have to be familiar with all your theorems. Theorem 1 up to theorem 9. Together with the converses and the corollaries on theorem 4. You have to be familiar with them. When you're answering the geometry question, you must look for the following. 1, you look for the diameter, you look for the center, you look for the radius. Obviously the diameter and the radius, they are connected to a certain extent. You must look for cyclic quads. Okay? Under cyclic quads, you look for butterflies and so on. Okay, like in this question here, there is more than one butterfly there. You look for tangents. Also, you might have to identify some chords. Okay? Don't start answering the question without identifying any of those. Because those 6 are connected to theorems. Okay? And when you're answering the questions, you need to have a strategy. Okay? You need to have a strategy. So the first strategy is to identify what. Right, so in this question, this is how I'm going to approach the question to determine angle A1. Can you sit properly, please? Okay, to determine A1, I'm going to find B2 first. If I can get B2, it means I can say A1 is equal to B2 because they are angles in the same segment. Okay, that's how I'm going to approach it. I don't know how you did it, but that's how I'm going to approach it. So first thing, I need to prove that this angle is 90 degrees. So in triangle CBE, okay, this angle here, that is CEB, is 90 degrees, but I need to write down why is it 90 degrees. So I'll say BEC is equal to 90 degrees. My reason will be line from center, perpendicular to chord. That is theorem 1. Yes. Well, why is this angle here 90 degrees? Okay, if you decide to say so, then it's fine. You can put
so wait for that now. How do you get that reason?
Well, if you want to put given, it's fine. But okay, to me, to be on the safe side, I'll put the theorem itself. Yes.
So if you were to say that BEC is equal to 90 degrees because of vertical opposite, how would you write that reason?
Okay. Obviously, you have to say AED is equal to 90 degrees. Then you write it's what? It's given. Then you say BEC is also equal to 90 degrees because it's vertical opposite to the first one. Okay. But I would prefer to write it this way, to be on the what? On the safe side. In actual fact, I'm not supposed to write given. Here it's not really like given, it's in given. By writing, okay.
So if you say vertically opposite, you get the same amount of marks.
Yes. You should get the same amount of marks. It's just that the approach will be different. Alright, so I've got that. Then I'll say in triangle, well, I'm going to use triangle BEC. So in triangle BEC, okay, B2 plus angle, well, this one here I can call it C2, that angle. But you have to indicate on the what? On the diagram. You have to indicate that you have called it C2. Don't just say angle C when there are 2 angles here. Okay, you have to name the angle. Especially if there's more than one angle, you need to be more specific. Plus angle what? BEC. This is equal to 180 degrees, which is sum of angles in a triangle. Okay, and from here, then we are going to say B2 is going to be equal to 180 degrees minus 90 degrees minus 33 degrees, and you get 57 degrees. Okay, so the answer there will be 57. So if you did the work, I hope you got 57. If you didn't do it, don't worry. There is going to come a time when you regret. Okay. Right? So that's what you're supposed to do. Then 8.1.2, that is calculating D2. Now, there is more than one way to calculate D2. Sorry, Ronan, are you part of the lesson or what? No, but you can't continue. There has to be eye contact. How would you feel if I was teaching you like this? You would end up saying, this teacher, he teaches us while he's looking down or like that. There has to be eye contact. Okay? There has to be eye contact. Alright. So D2 is this angle.
You didn't conduct 8.1.R. You didn't solve for A1.
Oh, alright. Okay. Let me conclude. Alright. Thank you for that. Just that I end up talking, so that caused me to get distracted a little bit. A1 is equal to B2. They are both equal to 57. So that will be angles in the same segment.
So,
Right?
that's right.
No, there's nothing like that. You'll get a 0. Right? Remember, I gave you a copy of the acceptable reasons. Don't forget that. Okay? Then to find D2, well, finding D2 is going to be very easy. D2 is this angle here. Well, I'm not sure how some of you did the question, but I'll do it this way. Well, this angle here is 90 degrees. Okay? And I know that my C2 is equal to D1, because they are angles in the same segment. So I can subtract 33 from 90, and I'll get the size of D2. Okay? Hope you can see that.
No.
This angle here, my C2, is equivalent to D1. They are angles in the same segment. Right, yes. Alright? So let me carry on. I hope you are following. And so that's not the only way. Okay? That's not the only way. You could also find angle A2 if you want. Since we know that this is 90 degrees, and this is 33, you have 33 plus 90, you get A2. A2 is equal to D2. Then that's also angles in the same segment.
How do you know angle B is not?
Because AC is the diameter. Alright, let me carry on.
So no, I'm not.
You are causing yourself to be lost. Because you are not going over your stuff.
You're leaving me behind.
Listen, at this stage, I expect you to know that AC is the diameter because it's written.
Yes.
It's written. That's why I gave you the work 2 days ago. You should be familiar with the question.
It's a theorem.
Because it is subtended by the diameter. Theorem 3. If I come and check your maths work of all the theorems that I told you, you don't have them. On top of that, I made a video of the lesson. What more do you want? How many letters in this country have a teacher who records the lesson in real time? Tell me, how many? Even before I go outside this school, in this school, who is doing it? Who? All right, let me carry on. Right, listen, okay, boys and girls, I gave you this worksheet 2 days ago, and I told that I'm going to go over it on Thursday. Over the past 2 days, you should have been busy doing every question. So that when you come today, you are familiar with every question. So that you can see the problems you actually had for the past 2 days. That's how you can learn better. All right, let me carry on. So I'm not going to have any regrets, no apologies for anybody who is not doing their work, who doesn't know what the teacher gave you. I'm not going to regret on that. Okay, let me carry on. All right, so let me calculate D2. So, as I said, there are two ways of getting D2. The approach that I'm going to use now is to determine the value of D1. So, to do that, I'm going to say angle D is equal to 90 degrees. That's angle in a semicircle. Please, it's not angles in a semicircle. It's not angles in a semicircle. It's angle in a semicircle. It's one angle that is subtended by the diameter. So you don't write angles. It's angle in a semicircle.
So, sir, in a sense, if you just write the X on the stick, it's wrong.
Well, as teachers, we end up marking it because we feel bad that the learner might end up failing if you start not giving a mark. But the correct way, it's angle in a semicircle. It's one angle, it's not two.
Where do you write angles?
When you're dealing with angles in the same segment, there are two angles that are equal. In this case, it is one angle subtended by the diameter. You understand that? Okay, then once you have got that, then you say D1 is equal to C2 based on my diagram. And both are equal to 33. They are angles in the same segment.
So if you write angles in the same angle, like say in the trick one, then knock it out.
It's a good question. You know, let me carry on. All right. Now that I've got that, then I'll say D2 is equal to 90 degrees minus 33 degrees, and that will give me 57 degrees. Okay, remember, the way that I've done it now is not the only way. Okay, it's not the only way. I've shown you a second method. Probably there's a third. So you answer it based on what comes into your head the moment you see the question. Okay, as long as you're using the correct geometric concepts, you are writing the correct reasons. Okay, so I'm done with, so I did 8.1.1, okay, then I've done 8.1.2. Okay, let me move on to 8.1, sorry, 8.2. Right, there's another question after this. Any question before I go? So, there's another question, this one here on the diameter. Yes.
They asked you to follow this week. We send the past papers to the group.
Okay. I thought I gave you. Okay. Well, I will say that. All right. Let's go over this question. So in this question, you are given the diameter is 20 centimeters. So your AC is 20, which means the radius will be equal to what? It will be equal to 10. Right? So the length of that radius there is going to be 10. So OC is 10, also OA is what? Is 10. Then DB, it is given there as 16, which means DE will be 8 and EB will be 8. Then the question says, determine with reason the length of OE. So OE is from here up to there, right? Okay, I need to just indicate that nicely. So it's from here to there. Right? This is the length that you're supposed to determine. Okay? My suggestion, okay, it's unfortunate that if you didn't see the question and this is your first time to see it, then you have issues. Like my suggestion would be make OE equal to X, okay, because it was not indicated, so you can say let OE be equal to what? To X. If OE is equal to X, it means that AE is going to be equal to 10 minus X, right? Now, if you look at the diagram itself, with all that information, it would be impossible directly to get the length of OE. So my suggestion would be construct a radar from the center to B, and also from the center to B. Okay, you do that construction. Yes.
So you not just use your properties of kite.
No. You can't use the properties of a kite until you prove that it's a kite.
Can you prove it?
No, I have to ask you that because you are coming with that thought.
I'm sure the study is.
No, you are coming up with that thought. You are coming up with that thought. So you have to prove to us that it's a kite. All right. It looks like a kite, but it's not a kite until you prove that it is a kite.
How can I prove this?
All right. You go back to your properties of a kite. When grade 11, I'm not supposed to teach properties of quant. Do you know that if you look at your work schedule, it doesn't say we should teach properties of quant.
The opposite end is like equal here.
Where are you getting that from?
Angle T and angle E is equal to each other.
Where did you get that information? Okay, this one we know that is 90, that one is 90. What about this one here and that one?
Angle A is 2 times angle C.
No. All right, let me carry on. Okay, let me carry on. So my suggestion is you construct two radii, OD and OB. Now we need to prove that. Why did we say that EB is equal to H? Okay, I need to write down the reason for that. All right. So the reason would be, I would say EB is equal to half of DB, right? My reason, line from center, perpendicular to chord. Okay? Then means EB will be equal to half times 16, which is 8. Right? You see, because we are not told that EB is 8, we have to use DB to prove why EB is going to be equal to 8. Okay? Then I will say, now I'm going to use triangle OBE to calculate the length of X, which is our OE. So I'll say OB is equal to OD. They are all equal to OC. And that is going to be equal to 10. But I think I should just write before this line, I have to write that OC is equal to half of AC. Okay, well, here the reason that you can say you can write OC is a what? It's a radius. The one there. That one will be very tricky to write it with. So this will be 10. Yes.
So if you allow the construction,
Yeah, for this one here, I would suggest that you do the construction. Okay, because directly, okay, the construction that I just did is just for the radar. Okay, it's just for the radar so that I can create a triangle that I can use the theorem of Pythagoras to determine the length of X. But if you can come up with if you can see another method or another way to get OE, you must tell me. I'm open to such a suggestion. Yes. No. Here, I can construct the two radii. Okay? It's much easier to construct a radii or to construct a diameter. Tangent
It's not wrong if you don't include it.
You what?
It's not wrong if you don't include it, you can calculate the lines.
Okay, before I answer you, do you know why I constructed the two radar? Yeah. If you understand why, then you must realize that this question here, it is very tricky to get the length of all without doing that construction. But if someone can come up with another strategy where you don't do any construction, I'm more than welcome to listen to that. How many of you were able to do the question? Yeah, I need to ask. How many of you? Yes, this question is. How many of you were able to do the question? Is there anyone who can say, I got the answer for this question? You see, the reason why you might have struggled was because of this construction that I just did. Okay, it is necessary for this question to construct the two radar.
So don't
you say something like OC minus AE?
OC minus AE.
Right, I hope you are aware that we don't know the length of BC, we don't know the length of CD, we don't know the length of AD, we don't know the length of AD. Because we don't know those lengths, the best route is to do it the way that I'm doing. Alright, let me carry on. I don't have too much time, so let me carry on. I'm still on the first question, okay, which means I may not be able to do all of that. Okay, so from there now, let's use the theorem of Pythagoras. So I'll say in triangle BCE, okay, if I use the theorem of Pythagoras, I can say OB squared is equal to EB squared plus OE squared. And this is Pythagoras. Okay? My OB is the radius. Okay? So that's what 10 squared. My EB, that's 8 squared. My OE, that's X. Well, I can put it as OE squared here, it's fine. Then I can just calculate it. OE squared. Alright, this will give me 100 minus 64 is equal to OE squared. Then I'll get 36 equal to OE squared. So your OE here is going to be 6 centimeters. Okay. Yeah, but I think that one you were given more information. So yeah, so it was much. All right, let me carry on. All right, just to give you a hint, do me a favor, please. I need to carry on now. All right, with this question here, hey, I need to carry on now. All right, so here we need to determine the value of DCB. DCB is that angle there, right? My suggestion before you carry on, you must label this 126, we can call it O1, and the reflex, we can call it what? O2, right? The obtuse 126, the reflex, can right? So for 9.1, it will be very easy. Yes?
Yes, it make a I understand problem. So that one will be 3 times angle at the same, 3 times angle at the counter.
Which one? Be more specific. Huh? Be more specific.
So C is equal to 2 times
Alright, here, first you must say O1 plus O2 will be equal to 360 degrees. These are angles around the point. Okay? Right? Then you need to calculate O2, so O2 will be equal to 360 degrees minus 126. And this will give you 234 degrees. Okay. Now here, DCB is a half of O2. It's half of the reflex. Okay? The obtuse, which is 126, is 2 times angle A. right? So then we say here GCB is equal to half of O2, right? Your recent angle at center is equal to 2 times angle at circumference. So what this means is that DCB will be equal to half of 234 degrees, and that will give me 170. Okay. Okay. The 9.2 prove that CDEF is a cyclic quadrilateral. Right. Your cyclic quad is this one here. In fact, it's not a cyclic quad, but the quad is this one here. You're supposed to prove that's a cyclic quad. Okay. Well, I'm not sure if you try to do the question, but this one is a very easy one, right? All you have to do is, if you can manage to prove that DCB, this angle here, is equal to angle E, if you prove that those two are equal, then that quad will be a cyclic quad. Yes.
I don't know if I'm understanding this correctly. So, O1 is going to be equal to 2 times less than the angle around A. Just hypothetically.
This angle here
Yes.
is 2 times that angle. The reason they are both subtended by the same chord, BD. Okay? And this angle here, the reflex, is 2 times angle DCB, because they are both subtended by the same arc. The same arc will be the major arc, which is that one. That arc subtends both angles. Alright? Also, O1 and angle A are subtended by the same minor arc, which is from here all the way up to there. Alright, let me carry on. So, all I have to do here, prove that DCB is equal to angle E. Then my reason will be converse exterior angle of a cyclic quad. But that's not the only way. If you don't want to do it that way, you can prove it based on opposite angles of a cyclic quad. Right? You calculate angle E, then you calculate that angle there. If the two add up to 180, then you can say, therefore, it's a cyclic quad because of converse opposite angles of a cyclic quad. Okay, but I'm going to prove it using exterior angle of a cyclic quad. There is no butterfly, so I can't use converse of angles in the same set. Yes? Yeah.
So how many reasons of that?
Okay, well, as I have told you in the past, with geometry, it's always better to provide as much information as you can. Okay? The more information you provide, the more likely you are to get full marks. If you provide less information, then you can disadvantage yourself. If you provide more information, it must be information that makes sense. Don't just write lots of things. No. All right. Yes.
So another thing, like, you know when you write extra, and then I can't just say that this mark for us, us three.
Not really. You see, in that case, it depends on the question. Right? If you are doing a question like this, you provide more information which is correct, but may not be necessary. You should get full marks. The only problem comes when you start providing information that's not correct. You see now, which is what most learners do. All right, let me carry on. So, I already know that I can find this angle here. Angle A and angle E they are co-interior, right? They are co-interior. So I'll say angle E plus angle A, I have to calculate it, okay? So So I'm going to calculate angle A. So to get angle A, I'll say angle A is equal to half of O1, right? My reason angle at center is equal to 2 times angle at circumference. So A1 is going to be half of 126 degrees, which will give me 63 degrees. Okay? Then I'll say angle A plus angle E. They add up to 108 degrees because they are co-interior angles. Then I need to state the lines that are parallel, that AB is parallel to EF. AB is parallel to EF. Can you please be part of the lesson? Be part of the lesson. So it means my angle E is equal to 180 degrees minus 63 degrees. And that will give me 117 degrees. Then I'll say since angle E is equal to GCB and both are equal to 170 degrees, I'll say therefore CDEF is a cyclic quad. Then you give a reason. Okay, why now you are saying it's a cyclic quad? It will be converse exterior angle of the cyclic quad.
So that converse is very important.
Yes, and this word converse is extreme. If you don't write it down, your answer will be incorrect. That word converse there is extremely important. All right. Okay. Still a good time to do another question. So let me carry on. Can you please be part of the lecture? All right. Then 9.3. Well, if I want to calculate the angle R, I don't know how you did it. This is my angle R. I need to find the size of maybe O1 or that one O2 there. I'll find O2 first. Okay? Angle O2 plus angle R plus Q1, they are equal. So O2 is equal to Q1 plus angle R. So if I can get O2, then I'm almost there. So the first thing that I'll say is to say OP is equal to OT. Why? Because these are what? Radii. Once I do that, then I can say, therefore, T1 is equal to angle P, and they are both equal to 28 degrees. And the reason will be, these are angles opposite equal sides. Okay? I'm almost there. Then I'll say, in triangle POT, angle P plus angle T1 plus angle O2, they add up to 180. That will be sum of angles in a triangle. Right? Then O2 will be equal to 180 minus 56 degrees, which will give me 124 degrees. Okay? Then from there now I'll say O2 is equal to angle R plus angle Q1. Okay? This will be exterior angle of the triangle. But Q1 is equal to 90 degrees. The reason will be tan perpendicular to radius or tan perpendicular to diameter. Okay? Okay. You have to write why Q1 is 90. Okay? You cannot just substitute the Q1 is 90 here without stating why you are saying the Q1 is equal to 90 degrees. So let me finish at the top there. I'll finish here. Now once I have that, means I can say O2 is equal to, or rather, well, let me substitute because I've already written that down. So I'll say angle R will be equal to O2, which is 124 minus 90 degrees, and my angle R will be 34 degrees. Okay. Do you have any question you can ask?
So, what's that word?
Where? Where? I'm talking about here.
No,
Yes. Huh? No, this one is bad. No, I wrote here bad. Okay, let me write it nicely. You have to understand that I'm a math teacher, so my handwriting is not like an English teacher.
And then that R is supposed to be P. The R on the top is supposed to be P.
Which one? I'm talking about this one here.
On the diagram, so on the top of the
Yeah, this one is a P.
Yeah, it's supposed to be a P.
It's a P there. Right. Okay, any other question? Challenging, but it's not. Alright, first thing, name three other angles equal to x. First thing, this angle here is equal to angle R. Okay? Because of the tan chord theory. So PS is the tangent and QS is the chord which subtends angle R. So you say angle R is equal to angle S1. Both of them are equal to x. The reason will be tan chord theory. Every time you see a tangent, if you see a tangent in a question, what must come into your head straight away is the tan chord theory. I told you about it. So even in your control test next week, if you see a tangent, it means somehow you have to use what? The tan chord theory. Don't start getting confused and looking for other things elsewhere. The moment you see a tangent, tan chord theory. Okay? There's no need for you to get scared. And if the tangent is there, it means you need to use one of the three tangent theorems. And the most common one is the tan chord theory. Tangent from a common point is not very common. Like in this case, it's there. You have got P, Q, and PS. They are tans from a common what? Point. Now, that scenario is not a very common one. The most common one where you have one tangent. Okay? That's when you're supposed to use what? The tan chord theory. Alright, so tan chord theory. Then, since PT is parallel to SR, it means this angle T1 is equal to angle R. So T1 is equal to angle R, they are both equal to X. There is corresponding angles. Then you state the lines that are parallel. PT is parallel to to line SR. Those two are parallel. Okay? Right. Now these two were straightforward, you could see them easily. The third angle, okay, you have to start by saying PQ is equal to PS. And you write the reason here turns from the common point.
So you're not in P2.
Okay?
So you're not in PS.
No. Then from here now you say Q1 is equal to S1. They are both equal to X. And your reason will be angles opposite equal sign. Okay.
Wait, so